In the quiet coastal town of Minamata, Japan, nestled along the Yatsushiro Sea, a tragedy unfolded that would forever change environmental policy and human health awareness. This is the story of Minamata disease, one of the world's worst cases of industrial pollution. Cries for justice echoed through the streets as Minamata victims and loved ones demanded answers. But to understand their struggle, we must go back to the origins of this devastating catastrophe. In Kumamoto Prefecture, Minamata flourished as a fishing community. The surrounding marine biome supported an abundance of life, from fish and shellfish to birds and mammals. The interplay of ocean currents, sediment composition, and local climate created an environment rich in biodiversity. But beneath the surface, a silent threat was building. Since 1932, the Chisu Corporation, a major chemical company, had been discharging wastewater into Minamata Bay. This wastewater contained methylmercury, a highly toxic compound. Over the years, this invisible pollutant bioaccumulated in marine organisms, increasing in potency as it moved up the trophic levels. Top predators such as large fish and shellfish accumulated the highest concentrations, creating a devastating effect on the locals who relied on them for food. By the 1950s, residents began experiencing strange symptoms: numbness in the hands and feet, muscle weakness, and vision and speech impairments. In an article by the National Library of Medicine, typical symptoms included tremors, sensory disturbances, poor articulation, and even paralysis. The most vulnerable were children, some of whom were born with severe neurological disorders thought to be cerebral palsy. Scientists and doctors were baffled, but on May 1st, 1956, the outbreak was officially identified as a new disease later named Minamata disease. The effects of mercury poisoning were devastating. In March 2001, the Japanese government recognized 2,265 victims, although over 10,000 have received financial compensation, and the number of total victims is likely higher. The impacts extended beyond humans. Fish populations dwindled, shellfish perished, cat dancing or cat suicides occurred, and seabirds displayed erratic behavior. The sediment and water chemistry of the bay became dangerously altered. Still unbeknownst to humans, mercury was trapped and settled in the bay floor where it continued to poison the ecosystem for decades to come. In late 1958, Chisu was under investigation for the contamination in a harbor connected to the bay, so they dumped wastewater into the Minamata River instead. The flow of the river spread the mercury to other nearby villages. According to the Minamata Disease Museum, the cat experiment was conducted by Chiso Hospital in 1959, aimed to detect the causative substance of Minamata disease. When Dr. Hasakawa fed wastewater from the process that produced acetaldehyde, one of Chisu's main products at the time, to the cat, it exhibited the same symptoms as the patients. Not only did Chiso deny that its wastewater was responsible for the pollution, the company also ordered him to stop the experimentation on cats. For decades, the victims and their families fought for justice. In 1968, the Japanese government officially recognized the disease as mercury poisoning caused by industrial pollution, and the Chiso Corporation ceased dumping wastewater in the bay, although researchers suggested mercury was the cause and action should be taken a decade earlier. Over an estimated 27 tons of methylmercury were dumped into the bay. It took years for victims to receive proper compensation, if at all. In 1977, environmental rehabilitation efforts began, titled the Minamata Bay Pollution Prevention Project, aiming to restore the damaged ecosystem through dredging out mercury from the sediment, limiting the spread of fish outside of Minamata Bay, and biological remediation efforts. The project ended in 1990 after 48 billion yen, or roughly $500 million were spent.
In 1959, I heard that Minamata disease was caused by fish contaminated with waste liquid from Chiso by the executives of the fishery cooperatives. The protest began on November 2, 1959. Now that I think about it, when we protested to stop that, if Chiso had stopped discharging wastewater, if the government also instructed companies not to discharge wastewater, I've always believed that it would not have become such a terrible tragedy, and that it could have been prevented somehow to a minimum.
The legacy of Minamata reaches far beyond Japan. Today, Minamata Bay has seen partial recovery, but it remains under close observation. Fish populations show mixed signs of resilience, with some species adapting while others still bear high mercury levels. Mercury persists in deep sediment layers, posing a risk of recontamination if disturbed. Scientists continue to study the long-term ecological succession of the bay, analyzing how natural recovery processes interact with human intervention. Minamata stands as a reminder that environmental disasters do not end with immediate consequences. Their effects ripple through generations.
Scientists and lawmakers have emphasized early detection, environmental monitoring, and bioaccumulation research, driving stricter regulations, greater accountability, and faster crisis responses. In 2013, the Minamata Convention on Mercury was adopted globally to prevent such tragedies by over 140 countries. Minamata has now become environmentally certified and identifies as an eco-town since 2001. They work to create parks, learning centers, and are even working to become a zero-waste society. The United States Environmental Protection Agency estimates global sources contribute to 70% of mercury deposited in the United States. As individuals, we must advocate for responsible consumption, corporate transparency, and sustainable practices. By learning from Minamata, we can prevent similar disasters and safeguard the health of future generations.